Hello, this is Notes, Chapter 2, Section 2, continued. It's the continuation of distance and midpoint formula section, but this time we're going to be looking at the circles here. Let me pick a pen. Okay, this part here is on circles. Why is this not writing? All right. There we go. Circles. All right, definition of a circle. A circle is a set of all points in a plane that are equidistant, which means same distance from a fixed point, called the center of the circle. The fixed distance from the circle's center to any point on the circle is called the radius. So if we look at the diagram right here, this point right here is our center. That's the center point of the circle. And all the points, all the points on this circle right here are the same distance from this center point, that center point right there. Okay, so from the center to any point on the circle, that distance is called your radius, which you're already familiar with. You've had geometry. Now, the equation of a circle comes from the distance formula. If you recall the distance formula in the last section, d, the distance, is equal to the square root of the difference of the x's squared plus the difference of the y's, which came from Pythagorean theorem. Distance is actually the length of the radius from the center to the circle. So in this case, this is going to be our d in the distance formula. Okay, and I could, to illustrate, I guess I'll try to use the pink. I could drop a perpendicular, and this would be the distance or the length for that's parallel to the x-axis, and this would be the length or this difference right here, since it's parallel to the y-axis. And I'm going to get rid of that. There we go. All right. So it does come, the equation of a circle comes from the distance formula because, for this length of the radius, that's really the distance formula on the coordinate plane. And so we can then replace the d with r, since we know that is the radius. Okay, so the radius of a circle equals this thing here. Now, notice I changed from x sub 1 to h, and this changed from y sub 1 to k. The center of the circle has specific coordinates, hk. It's because it's a special point on the coordinate plane. X, y is any one point on the circle, whereas hk represents the center of the circle. And so we replace this x1 and this y1 with the coordinates for the center of the circle, hk. Now, when we square both sides of this expression right here, which I'll highlight in yellow, when we square both sides of that expression, what ends up happening is you're going to get r squared equals, well, if I square a square root, takes the square root symbol away. They're inverse operations. And so I end up with this, r squared equals quantity x minus h squared plus quantity y minus k squared. And so the standard form of the equation of a circle with center hk and radius r is this. Okay, and when the circle's equation is in this form, it's really easy to pick out the center. And it's really easy to find out what the radius is. So, right here in this example, it says, write the standard form of the equation of a circle that has a center 0, 0, and a radius of 4. Well, this right here is my hk, and this is my r. So I would put a 0 in here. X minus 0 my pen writer wants to write, plus y minus 0 squared equals r. R is 4, but don't forget about the squaring. And when you clean this up, you end up with this right here. X squared, because x minus 0 is x, and you got to keep the squaring. Y minus 0 is y, you keep the squaring, and then you square the 4, you get 16. Now, to do this backwards, to find out what the center is, well, you would just, x minus what? 0 would be x squared. And you could see that the center of the circle of this equation is 0, 0, and to get the radius, you would take the square root of this number. All right, this diagram over here is showing us how to graph it. Well, we're going to plot the center, 0, 0. If the radius is 4, you're going to plot 4 points on the circle. 1, 2, 3, 4, straight up, straight down, 4 units, to the right, 4 units, to the left, 4 units. Okay, you get these 4 points. Now, I promise I won't make fun of your flat circles if you don't make fun of mine. I can't draw a perfect circle. The only way I could get a really good circle is if I use a compass. So this is how you're going to graph the circle. You're going to plot the center. You're going to use the radius to plot 4 more points. From the center, you're going to go up and then down and then left and then right. However many units the radius is, in this case 4, right? It would be 4 squared, that is 16. And then you draw the circle as best as you can. Now, for these problems, you need to use Cartesian coordinate paper, okay? Now, what is this business over here about? Well, this is talking about the domain and range. All right, so we know the domain are all the x values that we found on the graph of this circle, and the range, same thing, all the y values. The domain, again, are your x values. The range is your y values. So for the domain, it's farthest left and farthest right. Okay, so the first x value that would show up on this circle is -4. The last x value that would show up on this circle is +4. So the domain goes from negative to +4. The range, the same thing. The lowest y value and the highest y value. I'm going from -4 to +4. Okay, now that's not always going to be true if my circle's up here in quadrant 1. Okay, it just so happens it's because the center of the circle happened to be 0, 0. Okay, so if you have any questions, post on the homework discussion or ask in a Google Meet. This week you'll have to meet on Tuesday, Wednesday, Thursday, and Friday. Thursday you have a quiz coming up, and your regression project is due on Thursday as well. So make sure you get any last-minute questions answered in your Google Meet before that day. All right, the next part of this. We could graph circles on a graphing calculator, but you do have to solve the equation for y. Now, don't make this be something that's really all that difficult, because it's not. If you're solving the equation for y, that means you want to get this y by itself. So if I want this y by itself, I'm going to take this x squared and subtract it over. And I'm just going to keep it like that. I'm not going to switch it and make it negative x squared plus 4. Nope, I don't need to. And then to get rid of the squaring on the y, I have to do an inverse operation, right? That's what equation solving is all about. It's all about inverse operations. So all you do is square root both sides. Okay? And you're going to be left with y on this side. Remember, when you take the square root for solving purposes, you always need plus or minus. It's going to be plus or minus the square root of 4 subtract x squared. This is a quantity under the radical. So if you, on your TI-84, type in, you go to, I would clear the memory, second plus 712, clear the memory, and you go into y1 and type in positive, you don't need the plus sign, you just type in square root of 4 minus x squared, and then hit enter, and it goes down to the second field where you could type another y equals equation in. So go down to y2 and type in, make sure you hit the negative, don't hit the minus button, hit the negative, okay, and type in the square root of 4 minus x squared. And then on the graphing calculator where your screen is, You know, this button over here says graph. One of them says zoom. So if you hit zoom and then choose the one that says square, zoom square, it's going to make your circle nicer. Otherwise, if you don't choose zoom square, your circle might look like an oval. And the other thing I want to mention on the graphing calculator, you see this part of the circle is the positive part, so it's going to graph the top of your circle. And then this is the negative part. It's going to graph the bottom of your circle. And you'll notice on the graphing calculator that for whatever reason, I'm not quite sure why, but there's going to be a gap here. And again, I don't know if it has something to do with the pixels or what the deal is. But don't worry about that because there are points there on the graph of the circle. We'll talk about that more in detail if and when, hopefully, we're back in the classroom together. Okay, so again, don't let solving the circle's equation for y be something that's all that difficult. And if you zoom square it, it's going to give you a nicer looking round circle. And one more thing, when you do look at that circle on the graphing calculator, it might not be fully connected there. Okay, so that's how you would put it on the graphing calculator. You know, this plus or minus is saying, you know, the first part is the top of the circle, the second part is the bottom of the circle. All right, this part of the notes. Write the standard form of the equation of the circle given the center and the radius. Okay, so now we're going to do this backwards a little bit. This is h, this is k, and this is r. So you're going to substitute. Now your model is x subtract h and y subtract k, squaring on those quantities, and then r squared. So you're going to take your h, your 5, and substitute it in, right? And your -6 and substitute it in. And then your radius of 10 and substitute it in for r. Now, you do have to raise this to the second power. You can't just leave this as 10 squared, so please be cognizant of that. Also, you can't leave, you know, a double negative in here. You know, this is y subtract -6. When you have a double negative, it really means the opposite of that sign. Okay, this is x, the opposite of 5 would be, you know, -5. That's why it turns out to be x minus 5. So remember, clean this up here, this double negative, into a positive, and always square this out. Okay? So here I can clearly see, oh, yeah, my center is 5, -6, and my radius is 10. So again, if you have any questions, post on the homework discussion or ask in a Google Meet. Here says, find the center and the radius of the circle whose equation is this, and then graph the equation. Well, the center, you know, this should be x minus something. X minus what would be +3? Well, that's -3. All right, and of course that's squared. And this would be plus... Sorry about that. This pen writer's not working out too good for me today. Y minus something. Quantity squared. Well, that would be +1. And then what squared is 4? Well, that would be 2. 2 squared. Okay, so if I'm looking here, I see the -3 that I set up, the +1 that I set up, and the 2. So my center is -3, 1, and my radius is 2. Okay, so h is -3, k is +1, the center is -3, 1, and the radius is 2. Remember, when you have your groupings like this, it's never the same sign. It's always the opposite sign. Always, always, always. All right, so how do we plot this? Well, you plot the center. You go to where x is -1, -2, -3, +1. There's my center. My radius is 2, so from the center, I'm going to go up 2 units. From the center, down 2 units. From the center to the right, 2 units. from the center to the left 3 units. Okay, there's my 4 points on the circle. I could identify those 4 points if I wanted to. You know, this ordered pair is -1, +1, and so on and so on. The domain of this circle, I'm going to put it in brackets because it's included, okay? Domain is x's farthest left. Well, from the origin here, I'm going 1, 2, 3, 4, 5, -5 to -1. The range, that's my y's, the lowest y and the highest y. The lowest y is -1, and the highest y is 1, 2, 3. Okay, so that's how I'm going to give the domain and the range of my circle. Okay, so it's farthest left, farthest right. Now on the TI-84, I could take this equation and solve it for y. Now, you might think, oh my gosh, that's so difficult. It's really not that difficult. Let's look at the steps. Here's my original equation. The center was -3, +1, radius is 2. I want to get the y by itself. So I'm going to take this whole entire thing right here to the other side by subtraction. And that leaves me with a y minus 1 squared equals 4. Subtract this thing that I highlighted in green. Now I want to remove the squaring, so I square root, and here's where my plus or minus the square root of this, what I call chunky monkey, on the other side. And the last thing to do to get y by itself is to get rid of the 1. And the opposite of subtracting 1 would be to add it. And we always put it in the front. Okay, so the first equation in your graphing calculator would be 1 plus the square root of that. And the second equation would be 1 minus the square root of that. Again, this will graph the top of your circle. This one will graph the bottom of your circle. Try it out on your TI-84 if you have one. Okay, so again, don't let this, solving this for y, be something that's all that difficult. It's really not that difficult. So if you have questions, please post a comment or ask in a Google Meet. All right, one last thing we have to do here in this notes, because I believe this was 3 pages, is talk about the general form of the equation of a circle. This time the general form is always set equal to 0. And you'll see here, we can't easily pick out the center and the radius when it's in this form. X squared plus y squared plus dx plus ey plus f equals 0. You know, this d, e, and f, they just represent coefficients and a constant. That's all that is. All right, so if I want to convert the standard form to the general form, all you have to do is multiply this out. Okay, you're going to square this binomial. Square the first, x squared. Square the second, +4. First times second, -2x, doubled, -4x. Same thing here. Square it, multiply, then double. Gives you this. Equals 9. Now remember, the general form is set equal to 0. You need 0 on this side. And you are going to have some like terms. So I like to remove grouping symbols and then bring this. Notice I brought that over right there. So I just copy down x squared minus 4x plus 4 plus y squared plus 8y plus 16 minus 9. I have like terms to combine. Okay, I have a constant here. I have a constant here. And I have another constant here. Okay. 4 plus 16 is 20, subtract 9 is 11. Okay, and it's customary to put this in order of descending powers, and the x's before the y's. So it's x squared, y squared, then your x linear, your y linear, and then your constant. Okay, so you just combine it and rearrange it. It's quadratics first, x first, then y, then linears, x first, then y, then constant. This is the general form of the equation of a circle. Now, what's even more fun than that, because it's not too terrible to square out some binomials and rearrange the terms. The thing that's even more fun than this, in my opinion anyway, is to actually take this equation and put it back in this form. And that requires completing the square. Not once, but twice. Hey, that's a lot of fun. All right, so that's the next thing we're going to take a look at. Convert the general form of the equation of a circle to the standard form and then graph it. All right, so let's take a look and see what happens here. Convert the general form to the standard form. General is set equal to 0. I want to put it in standard, or so that I can see what the circle's center and radius is, so I can graph it, okay? Because I can't graph it when it's in this form. Okay, so I want to graph it. I need to know what the center and the radius is. Now, you are going to complete the square not once, but twice, okay? Got to complete the square twice. So what you're going to do is you're going to put these x guys together right here in this grouping. X squared, 4x. And then you do plus space because you're going to complete the square here. And then you're going to do the same thing in a separate grouping. You're going to put the y's together. Y squared minus 4y plus something. And you're going to boot the constant to the other side. That's a rule of completing the square anyway. So I get this 1. Okay, that's where this 1 is coming from. Now, I'm going to be technically adding 2 things to the left side of the equation. So I need to show that I'm adding 2 things, those same 2 things, to keep the equation balanced. All right, the rules for complete the square. Leading coefficient has to be a 1. It is on both of these. Okay, so you take half the middle guy. That's 2. Square it. That's 4. And you add it to both sides. Once here and once here. Okay, once here, once here. All right, same thing here. Half of negative 4 is negative 2. Negative 2 squared is 4. Add that 4, not just there, but here as well. They're not always going to be 4s, okay? It just depends on what this is. All right, so here's my plus 4 plus 4. I have to add the 2 4s to the other side. This thing here is a perfect squared trinomial. It always factors into a single binomial squared. So is this. That will always factor into a single binomial squared. 4 and 4 is 8 plus 1 more is 9. So guess what? The center of my circle is not positive 2, negative 2, not negative 2, positive 2, and not 9, the square root of 9, which is 3. Now I can take this information and graph it. So I go to where x is negative 2, y is positive 2, and plot my center. My radius is 3, so I go up 3, down 3, to the right 3, all in terms of where the center is, okay, and then to the left 3. And then I draw my circle as best as I can. You can check this on the TI-84. Remember, you cannot use the TI-84 to do the work for you. This is going to be the work, and I'm going to know you know what you're doing by showing me the work. Okay, but on the TI-84, if you want to see if you're in the correct quadrant, if the circle should be large, if it should be small. On the TI-84, we're going to take this, and let me get rid of some of this annotation that I did here on the notes. Okay, so, you know, you can make this be a long, drawn-out thing, but really you don't need to. I know that I'm going to take this over here. You know, the quantity is going to stay the same sign. I'm just subtracting the whole quantity. Okay, so this I took over here by subtraction. This I got rid of by square root. And then this I got rid of by adding. Okay, so there's my 2 plus or minus 9 minus the quantity x plus 2 squared. Okay, so this would be the top of my circle, 2 plus that, and this would be the bottom of my circle, 2 minus that. Type it into the graphing calculator. Again, if you have any questions, you're struggling with anything, you know, post a comment for me or ask me in a Google Meet. Ask for a private Google Meet. All right, so right here is what you would be typing in on the TI-84. What's the domain of this circle? What's the range of the circle? Well, the domain is farthest left, farthest right. Yes, it's the x values. It's going to be parallel to the x-axis. So we're looking like 1, 2, 3, 4, -5 to +1. And the range of the circle, it's lowest to highest. Looks like -1, 2, okay, that's -1. That's 0. 1, 2, 3, 4, 5. Okay, so there's my domain and range. You know, the highest y value would be a +5. And, yeah, that looks pretty good. All right, so if you have any questions, post a comment, ask in a Google Meet. This is a homework assignment, 31 to 55 odd, but I also added number 55 for the honors class. So make sure you get that in a timely fashion. Some of you have been skipping some homework assignments. Please don't skip homework assignments. Please, 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 please don't skip homework assignments. Quiz is on Thursday. We have a little bit of time to do a review, ask some questions. So give a shout out if you're struggling with anything. All right, I'm going to be quiet now. Have a great day.